Every day, millions of Americans drive cars that over time have become increasingly fuel efficient. Almost all these vehicles have one thing in common that allows for this efficiency: the turbocharger. The turbocharger is a device attached to an engine that helps cars use fuel more efficiently by forcing more air into the engine, leading to increased combustion. Today, from family sedans to supercars, the turbocharger has become the norm for modern driving. But this was not always the case. In the early 1970s, the American government had a problem. The air quality in many major cities was so bad that visible smog layers blanketed many urban centers, leading to major health concerns. A major culprit? Automotive emissions and leaded gas. American consumers also had a problem. Due to an international oil crisis, they faced long gas lines, unreliable cars, and rising gas prices. That meant that the U.S. automotive industry had three competing problems: compliance with government regulations for vehicle emissions, improving automotive engine performance, and satisfying consumer demand for increased fuel efficiency. Ultimately, it was this dilemma that forced automotive engineers to come up with a solution, leading to one of the most revolutionary shifts in the automotive industry: forced induction and turbocharged engines. The commercial production of forced induction via turbocharging in internal combustion engines in the 1970s revolutionized the modern automotive industry, leading to comprehensive reform in engine design that today has become a standard feature in car manufacturing. Ever since the end of World War II, American car manufacturers and consumers have both prioritized performance over fuel efficiency. This was because at the time, gasoline was cheap, with the U.S. Department of Energy recording gasoline at less than 40 cents per gallon during the 50s and 60s, allowing consumers to favor high horsepower engines like V8 engines without worrying about fuel economy. This system worked well for consumers, as during the time, many people began moving to suburban areas, commuting longer distances, starting families, and traveling more for leisure. Because of this demand for large, comfortable, and high-performance vehicles increased, this led manufacturers to profit from spacious vehicles designed for comfort and power rather than fuel efficiency. However, the system began to change in the 1970s. Public awareness of environmental damage increased as thick smog began covering major cities like Los Angeles, where automobile emissions were identified as the main cause. In response to this concern, Congress passed the Clean Air Act of 1970, which put limits on vehicle emissions. Automobile manufacturers were now legally required to change their vehicle designs. At the same time this was occurring, the government mandated the removal of lead from gasoline due to its public health effects. Lead, which has been previously used to raise fuel octane and prevent engine knock, was now banned in fuel. Due to its removal, engines were now more prone to knocking and automobile performance was limited. These shifts allowed catalytic converters, devices used to reduce exhaust emissions, to be installed in vehicles since leaded gas destroyed them. As a result, all automotive manufacturers had to run unleaded gas, placing even more restrictions on performance. Then, in 1973, the pressure on the automotive industry intensified when the Organization of Petroleum Exporting Countries imposed an oil embargo on the United States in response to the support of Israel in what is known as the Yom Kippur War, also known as the OPEC crisis. Because of this, the U.S. was dependent on foreign oil. The oil embargo led to massive reductions in gasoline supplies, causing fuel prices to spike and leading widespread shortages. Across the U.S., Americans waited in long gas lines, gas stations ran out of fuel, and Americans for the first time began to comprehend that gasoline could be limited or expensive. In response to the embargo, Congress passed the Energy Policy and Conservation Act of 1975, creating the Corporate Average Fuel Economy Standards, regulations forcing automobiles to maintain a minimum fuel efficiency. Because of this, manufacturers were now legally required to improve their vehicles' fuel efficiency. These combined pressures on manufacturers forced the automotive industry in a corner, where in order to not sacrifice performance and meet expectations, engineers were forced to search for solutions that ultimately led engineers to survive in a changing world. These solutions engineers turned to at the time was turbocharging, a form of forced induction that allowed engines to keep their performance and meet standards through downsizing. Although turbocharging became widely used in cars in the 1970s, the idea itself dates back to 1905, when Swiss engineer Alfred Bucci patented a system that used exhaust gases to force more air into an engine. For most of the 20th century, turbocharging was not considered in automobiles. It was instead used in aircraft and industrial machines. As manufacturing improved, turbocharging became viable for passenger vehicles. Turbocharging worked by capturing exhaust gases that would otherwise be wasted and using them to spin a turbine connected to a compressor. This compressor compresses the air and forces more air into the engine cylinders, thereby allowing more fuel to be burned and increasing engine power. Because of this effect, turbochargers were allowed smaller engines to perform similarly to the same output as larger engines. Turbochargers directly addressed the challenges manufacturers faced in the 1970s. They allowed both consumers and the government to be satisfied while maintaining proper performance and fuel efficiency. Early turbocharged cars demonstrated this. The BMW O2 Turbo, introduced in 1973, showed that forced induction could boost performance in a road car. Later, the Saab 99 Turbo, released in the United States in 1978, used a 4-cylinder turbocharged engine to deliver performance on par with larger engines while consuming less fuel, which was extremely appealing to consumers at the time due to gas shortages and rising prices. These early cars proved that turbocharging could be reliable and practical for consumers. These cars helped the public perception by showing that forced induction was beneficial. As public perception grew, manufacturers began adopting turbochargers as a practical solution by integrating turbos into consumer vehicles. Manufacturers began downsizing their engines with great performance results. This marked a shift in the automotive industry, setting the stage for turbocharger adoption. Immediately following their introduction in the late 1970s, turbochargers changed the game for balancing performance and fuel efficiency. Turbocharging helped improve fuel efficiency by allowing manufacturers to replace large engines with smaller ones without sacrificing power. And now for the professional we interviewed, Professor Sam Akers from the University of Bath, a professional in internal combustion engine technology and turbo machinery.
The main reason for adopting turbochargers for automotive, so passenger cars, is really fuel efficiency. So although they increase the power, you can then put a smaller engine in. So rather than having a 5-litre V8, you could have like a 3-litre V6 turbocharged, or even a 2-litre 4-cylinder engine turbocharged. You can get the same amount of power, but you're doing that by recovering the exhaust energy.
American manufacturers also quickly adopted turbocharging. General Motors, an American automotive manufacturer, due to sales of the Buick, became the most successful American producer of turbocharged engines in the late 1970s. Buick was manufacturing tens of thousands of cars with turbocharged engines, making it the largest seller of turbocharged passenger cars in the U.S. at the time. Over time, sales numbers continued to decrease, with the Saab 99 Turbo selling worldwide and Buick's turbocharged cars remaining in production demand, proving that turbochargers were effective solutions at the time. In short term, turbocharging proved it could satisfy manufacturers, consumers, and the government. Consumers regained power with increased fuel efficiency, manufacturers met emissions and fuel economy requirements without losing sales, and the government got its demands met. This success confirmed that turbocharging was a viable solution at the time, allowing for its adoption even through the decades that followed. Today, the turbocharger revolution has become a standard in American car manufacturing. As emissions and fuel efficiency standards continues to increase in the decades that followed, turbocharging became an essential part of vehicles. Throughout the decades that followed, automotive manufacturers adopted engine downsizing, replacing larger engines with smaller turbocharged ones to meet CAFE standards. For example, the Ford F-150 shifted from large V8 engines to turbocharged V6 EcoBoost engines in the 2010s. During this period, manufacturers like Chevrolet, Honda, and Toyota also integrated turbocharged engines into their cars, showing that turbocharging had become a standard rather than a short-term solution. Today, turbocharging is a standard in the majority of American vehicles. It plays a crucial role in meeting governmental emissions and fuel economy pressures. In 2019, the U.S. Department of Energy released a study saying that 34% of all light-duty vehicles produced were equipped with a turbocharger, a significant increase compared to 1% in 2000. From the gas crisis of the 1970s to the cars we drive today, turbocharging sparked a revolution that changed vehicles forever.